This is the solution video for question 31 from part B of the 2019 ECAA paper. In this question, we're told P is the area of the region bounded by the curve y equals 5x minus x squared and the x-axis. And similarly, we're told Q is the area of the region bounded between the curve y equals 5x minus x squared, same curve we had here, and the line y equals 2x. And we're asked to find the ratio of Q to P. And we're given 5 varying ratios for possible answers for this. So we could try and do this question just with algebra and messing about with intersections, etc. But it's a lot easier to draw the graphs and try and make some intuition based on that. So let's try and draw what area P looks like first. So here's some axes, and we want to draw y equals 5x minus x squared. So we've got minus x squared, so we know it's going to be n shapes like this. And we see that we can factor an x out of this, i.e. the curve is y equals x, lots of 5 minus x. And so we know x equals 0 and x equals 5 are our two roots. So we know our curve looks something like this. So where now? Well, we know P is the area enclosed between the curve and the x-axis. So it's this area shaded in green. So now we want to work out the area of P. And we notice that we just need to integrate the curve between 0 and 5, and we'll get that area. So P is the integral between 0 and 5 of 5x minus x squared. So up the power to x squared and divide by 2, and up the power to x cubed and divide by 3, limits 5 and 0. Fortunately, when we shove 0 in, we'll get nothing here at all. So we just need to look at 5. So we have 5 over 2 times 5 squared, minus a third times 5 cubed. 5 cubed is 125 for both of these. So we have 125 over 2, minus 125 over 3. And then by either converting to common denominator of 6 and calculating it all out, or noticing that a half minus a third is a sixth, we get that this is 125 over 6, and so we have our area of P. So similarly, we'd like to try and draw what area Q corresponds to, and maybe we can work out the area of Q with the help of that drawing. So we need to have a chance of doing that where this curve y equals 5x minus x squared and the line y equals 2x intersect. So let's say 5x minus x squared is equal to 2x. Well, let's move the 2x over. For 3x minus x squared is 0. And we can take a factor of x out of this to get x, lots of 3 minus x is equal to 0. So for this we get x equals 0, which is the obvious intersection point between these, because we know this goes through the origin and this is clearly a line that goes through the origin. And we get x equals 3 as our other intersection point. So we know that our shaded area is going to look something like this. We know the line goes under the curve because the curve bends back round, so the line couldn't possibly over the curve, as then it would never enclose an area. So we know that this is the area we're looking for. So we know now for Q, we need to work out this integral. Why is this? Well, we want the difference between these two lines, so the curve minus the line, so 5x minus x squared minus 2x, and we know we need to do it from 0 to 3. So let's work out this integral. So let's move the minus 2x into the 5x to get minus x squared plus 3x to integrate, and then raise the power by 1 and divide through, so x to the 3 times minus a third, and 3x to the 2 over 2. With limits 3 and 0. The 0 will give nothing here, so we just need to look at the 3 case. So we have minus a third times 3 cubed, plus 3 over 2 times 3 squared. 3 cubed over 3, so that'll be 9. So we have minus 9 plus 3 cubed, which is 27 over 2. But we know 9 is 18 over 2, so this whole thing will be 9 over 2. And so we know the area of Q, and we're almost there. So we know Q is 9 over 2 and P is 125 over 6. So we just need to find the ratio of Q to P, which we could claim is 9 over 2 to 125 over 6. But clearly that's not going to be any of our answers because these are fractions in a ratio and that's not the best form for a ratio. So let's get it to integer to integer, and then maybe it'll match one of these. So let's times both sides by 2 to get rid of the fraction on the left, to get 9 to 125 over 3. And do the same with the right, times both sides by 3 to get rid of the fraction on the right, and we get 27 to 125, because 9 times 3 is 27. And we see that that matches option A in our multiple choice, and so our answer is A.